Come, team, save John Connor. This is the rockin' Moroccan man, Saeed Alawi. Anyway, I'm hoping you guys are having a happy and a wonderful Thursday night, as I'm having right now. Just a little status update about the project. Whoa, that was crazy. Anyway, so as you might have seen from the previous messages on Slack from Jared and myself, there was some issues regarding the pendulum moving left in a steady fashion, motion towards the left because of reasons. Anyway, what I'm trying to say over here, as you can see in the video right now, the pendulum is relatively stable. Sometimes it goes crazy, like you might have witnessed at the beginning of this video, but overall it is working. So we can kind of say that stage 1 is cleared. Now we can work on stage 2 of this project. It took me a little bit of thinking, fiddling, and pulling my hair out to just like think of some kind of solution, but I had kind of a eureka moment today during class, and let me just explain to you guys how it does work. So forget about this thing right now, don't pay attention to it. I want you to focus on these two guys right here and precisely these three guys right here. So the first line is the position error. I have the position, which is the current position, and +1. So what I notice is that the code as it is right now, the pendulum starts at coordinates -1 for the x-axis. There is no y-axis, so it's one-dimensional, but -1. So I subtract the current position by the initial position, which is -1, so it gives you +1. So that's what explains this line right here. So pos E, so it's pretty much position error, and anc E is the angle error, or in other way, how far is like what's the angle of the pendulum away from the zero angle, which is completely perpendicular from the horizontal plane. And the action is using the PD controller. There's no I in this controller because there's no I in team. Ha ha ha, I'm so funny. Anyway, so the issue there was before, as Jared pointed out, was that once you compute the action value, the angle is never ever completely zero. There is always a very small value. I'm gonna show you right here. Crazy stuff. Anyway, so as you can see over here, the angle is very small, but yet is still there. So you always have some sort, well, before I improved the code, there was always some sort of force applied on the bot. So I was thinking that maybe if the value of the angle is just really small, we can just use a velocity of 0. So that's what I did over here, and that's what I think is preventing the bot to keep on moving towards the left as it used to do before. But that's not everything. So even if you put like really small value, like if you dismiss like really small angle value, you can see over here like sometimes, well, I dismiss right now, but sometimes it does push just a little bit because you have the angle of the pendulum. It keeps on moving either right or left at a very small rate, but it is still there. And like if it keeps moving like at very small rates, a certain period of time, you have an angle that is bigger than 0.001, and you need to stabilize the pendulum again. So when you stabilize it again, then you have a certain shift to either the left or the right, but most of the times, if not all the times, it is going towards the left. So that's when I included these two lines right here. So what I'm trying to accomplish over here is that the position error is smaller or is between negative 0.1 or 0.1. So give us like a 0.2 interval where the current position, okay, I don't know how to word this correctly. The current position should not deviate away from the position that we want for more than 0.1 points from the initial from the desired position. So you could have seen just right now, that's what's happening right now. So it moves just a little bit away and tries to correct itself. So I think these two lines right here, we can keep them to help us move the pendulum from point A to point B. So if you can change the initial point from -2 and the desired point to coordinate 2, then we can just update this to have like pose -2 and use these two lines to apply some force. For the value 50 and -50, it's kind of arbitrary right now, but what I notice, if you apply too little of a force, you don't correct the position of the pendulum good enough. But if you apply too big of a force, then you have a higher risk of dropping the stick to the ground, and we don't want to drop the stick to the ground. That's nasty. Ew. Yeah, well, that's all I had to say today about this project. I just wanted to share with you guys, so I can push this on GitHub and you guys can have fun with it all weekend long while I have fun with other projects. Have fun, and don't forget to pull your dicks out and swing in the air like you don't care. Baby, yes please, any day. Alright, have a good night and Godspeed.